On the 1st of July, NASA detected a mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all.
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
On July 1st, NASA detected a mysterious object speeding toward Earth. And some actual bona fide experts think it might not be your typical space rock, or maybe any kind of rock or natural phenomenon at all, but a nuclear-powered spacecraft sent by an alien civilization to observe us. 3I Atlas. An interstellar visitor moving at over 200,000 kilometers per hour on an inexplicable path is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory that this may actually be a piece of alien technology.
Supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
Harvard's astrophysicist Avi Loeb, who previously suggested Oumuamua might be alien technology, has co-authored a provocative new paper asking whether 3I Atlas could be a disguised probe from another civilization. On a scale where 0 means it's definitely a natural object like a comet, and 10 means it's definitely a technological object, Loeb places 3I Atlas somewhere in the middle, refusing to dismiss either possibility. The discovery happened thanks to the Asteroid Terrestrial Impact Last Alert System, which is what ATLAS stands for. Operating out of Chile, this new telescope, built to track fast-moving space objects, caught a comet from beyond the solar system moving across the sky.
A new telescope built to track fast-moving space objects in Chile has caught a comet from beyond the solar system moving across the sky.
When astronomers first spotted this object, they immediately knew something was different. Its orbital eccentricity is well above 1, which means it's not gravitationally bound to our sun. This thing is just passing through, and it's doing so on one of the most extreme interstellar trajectories we've ever recorded. But here's where it gets interesting. The object isn't just any random space rock tumbling through the void. The initial observations revealed something that made scientists do a double take. 3I Atlas was displaying characteristics that seemed almost too convenient, too perfectly timed. Its approach angle, its speed, even the timing of when we'd be able to observe it best. Everything seemed to align in ways that defied the randomness we typically expect from natural celestial mechanics. Now, here's where things get really interesting, and it involves a fundamental question about what we're actually looking at. The Hubble Space Telescope has been tracking this visitor, capturing detailed images that reveal a distinctive glow pattern. What scientists discovered is that this glow has an unusually steep brightness profile, much steeper than what we typically see in solar system comets. This brightness pattern is raising some profound questions. You see, when we estimate the size of objects in space, we usually assume they're simply reflecting sunlight. Using this standard model, 3I Atlas would need to be roughly 20 kilometers in diameter to produce the brightness we're observing. That would make it absolutely massive, potentially 40 times larger than our previous interstellar visitors like Oumuamua and 2I Borisov. But there's a problem with this calculation. Objects that large simply don't exist in the quantities we'd need to explain regular interstellar visits. The universe doesn't have enough massive rocks floating around between the stars to make this scenario plausible. We're talking about statistical impossibilities here, the kind of odds that make scientists extremely uncomfortable. If you enjoyed the video, make sure to hit that subscribe button and ring the bell so you never miss a future episode. Feel free to share it with your friends too. It helps support the channel, and I'm excited to keep bringing you even more fascinating content. But here's where Avi Loeb and his colleague Eric Quito have made a startling observation. The brightness profile they're seeing is consistent with something completely different. You have an object that's producing its own illumination rather than just reflecting light from the sun. Think about the implications of this for a moment. If 3I Atlas is actually self-luminous, then it could be dramatically smaller than we initially calculated. We're talking about the difference between a 20-kilometer behemoth and something potentially just hundreds of meters across. That's not just a minor adjustment, it's a complete paradigm shift in how we understand this object. And here's why this matters so much. the statistical probability of finding a genuine 20-kilometer interstellar asteroid is virtually zero. Loeb's calculations show that the limited reservoir of rocky material drifting between the stars could only deliver such a massive object to our solar system, perhaps once every 10,000 years or longer. The universe simply doesn't have enough large rocks floating around in interstellar space to make frequent visits plausible. But a smaller, self-illuminating object? That changes everything about the probability calculations and opens up possibilities that are frankly mind-bending. So what could cause an object to generate its own light? There are several possibilities, and not all of them are natural. Radioactive decay from heavy elements could produce a glow, though finding enough radioactive material in interstellar space would be extremely unlikely. Thermal emission from internal heat sources is another option, but that would require the object to maintain temperatures well above what we'd expect from solar heating alone. Or, and this is where things get really intriguing, we could be looking at artificial illumination from some kind of technology. If 3I Atlas were generating its own light through some kind of nuclear process, it would need to produce roughly 10 gigawatts of power. That's equivalent to several large power plants running continuously. Maintaining that kind of energy output over the millions of years of interstellar travel would require either an enormous fuel supply or technology far beyond our current understanding. The spectroscopic observations from Gemini South and the NASA Infrared Telescope facility have revealed strong water ice signatures mixed with carbonaceous minerals and silicates. The water ice shows characteristics suggesting it could be chemically pristine, lacking the heavy isotopic signatures we typically see in solar system comets. This water could have formed billions of years ago in a completely different stellar environment, giving us a direct window into how planetary systems form elsewhere in the galaxy. But even this cometary evidence doesn't settle the debate. In fact, it might unexpectedly support the artificial hypothesis. If 3I Atlas is indeed some kind of probe or spacecraft, the dust and ice we're observing could simply be accumulated material from its long journey through interstellar space, cosmic debris that's built up on its surface over millions or billions of years of travel. This is where the scientific method becomes both fascinating and frustrating. We have compelling evidence for both natural and artificial explanations, and the data we're collecting seems to support multiple interpretations simultaneously. Now, let's talk about that trajectory, because this is where the evidence for something unusual really starts to pile up. In their paper, Is the interstellar object 3I Atlas alien technology? Loeb and his collaborators present a statistical analysis that's genuinely unsettling. 3I Atlas is traveling on a retrograde orbit that's tilted only about 5 degrees from the ecliptic plane, where Earth and most planets orbit. The probability of this happening by random chance, they calculated, is roughly 0.2%. But it gets more intriguing when you look at the planetary encounters. This object is going to make remarkably close approaches to multiple planets. It'll pass within about 29 million kilometers of Mars on October 3rd, reach perihelion at 1.35 astronomical units on October 29th, and later swing within 33 million kilometers of Jupiter. The combined probability of a random interstellar object making such close approaches to 3 major planets? Approximately 0.005%. That's 1 in 20,000 odds. Think about what this means. If you were to randomly throw a dart at a map of our solar system from interstellar space, the chances of hitting such a precise trajectory that brings you close to multiple planets is astronomically small. Yet here we are watching 3I Atlas do exactly that. Either we're witnessing an incredible cosmic coincidence, or there's something more deliberate about this object's path. Here's another detail that's raising eyebrows among researchers. 3I Atlas reaches its closest approach to the Sun when Earth is on the opposite side of our star. We literally won't be able to observe it during this critical phase. If you were designing a spacecraft to conduct operations while avoiding scrutiny from Earth-based telescopes, this timing would be absolutely perfect. Loeb calls this a potential reverse solar Oberth maneuver, a high thrust braking strategy that could allow an interstellar craft to slow down and potentially remain in our solar system. The fact that this maneuver would be completely hidden from Earth's view by solar glare is either an incredible coincidence or evidence of deliberate planning. During this hidden phase, 3I Atlas could theoretically deploy instruments, change course, or even release smaller probes without us knowing. By the time it emerges from behind the sun and becomes visible again, any such operations would be complete. It's the perfect cover for clandestine activities, if that's what this object is designed for. Consider the complexity of calculating a trajectory that not only brings you close to multiple planets, but also ensures your most critical maneuvers happen when the dominant technological civilization in the system can't observe you. That level of precision suggests either extraordinary luck or extraordinary intelligence. Yet despite all this, many experts remain convinced it's a natural comet. But why? But let's be clear about the scientific consensus. The majority of astronomers studying 3I Atlas believe it's a natural interstellar comet, and they have good reasons for this position. David Jewett from UCLA, who's been analyzing the Hubble data, points out that 3I Atlas is displaying classic signatures of cometary behavior. The dust production rate they've measured, between 6 and 60 kilograms per second, falls within expected ranges for comet activity. The ejection velocities of 20 to 2,000 meters per second also match what we see in normal comets. Moreover, the fact that we haven't yet detected volatile gases like cyanogen or diatomic carbon isn't unusual. 3I Atlas is still about 4 astronomical units from the Sun, roughly Jupiter's distance. Most comets don't start showing strong gas emissions until they get much closer and solar heating really intensifies. The natural explanation also has the advantage of simplicity. We know interstellar comets exist because we've seen them before. We know they can have unusual compositions because they formed in different stellar environments. We even know they can have strange trajectories because gravitational interactions with other stars can send them on highly eccentric paths through space. The self-illumination hypothesis also faces significant challenges. If 3I Atlas were generating its own light through nuclear processes, the energy requirements would be staggering. We're talking about power outputs that would require either massive fuel reserves or technology that operates on principles we don't understand. The engineering challenges alone make this scenario seem unlikely, even if it's not impossible. Don't miss the next chapter in the 3I Atlas saga. Subscribe now and join the quest to uncover one of the biggest cosmic puzzles of our time. The next few months represent a critical observation window that could finally resolve this cosmic mystery. As 3I Atlas approaches the Sun, we should start seeing those telltale gas emissions if it's truly a comet. The James Webb Space Telescope has this object in its sights, and its infrared capabilities could reveal unprecedented details about its temperature profile and energy output. There's also an exciting possibility involving Mars-based observations. When 3I Atlas passes close to Mars in early October, there's talk of using the HiRISE camera on the Mars Reconnaissance Orbiter to capture high-resolution images. This could give us our best close-up look at an interstellar object's surface and potentially resolve the question of whether we're seeing reflected sunlight or self-generated illumination. But here's what really has scientists excited about the future. The Vera C. Rubin Observatory has just begun operations, and this revolutionary facility will detect dozens of interstellar objects annually. This means we'll finally have the statistical sample we need to understand what's normal and what's truly anomalous. If 3I Atlas turns out to be artificial, we'll likely see more objects with similar characteristics. If it's natural but unusual, we'll learn about the incredible diversity of interstellar visitors. The European Space Agency is also considering a rapid response mission concept that could potentially intercept future interstellar objects. While it's too late for 3I Atlas, the lessons we learn from this visitor could inform how we approach the next mysterious object that enters our solar system. Consider the implications if the self-illumination hypothesis proves correct. We'd be looking at an object that's not only artificially lit, but also following a precisely calculated trajectory through our solar system. That would represent the most significant discovery in human history, proof of visitation by another civilization. Even if 3I Atlas turns out to be completely natural, the brightness profile mystery is teaching us that interstellar objects can behave in ways we never expected. Whether it's exotic physics we don't understand or technology we can't yet imagine, this visitor is expanding our conception of what's possible in the cosmos. The scientific process is working exactly as it should. We have competing hypotheses, we're gathering data, and we're letting the evidence guide our conclusions. but the stakes couldn't be higher. If we're wrong about 3I Atlas being natural, we might be missing humanity's first confirmed contact with alien technology. The fear that some scientists express isn't about the object itself, but about what it represents. If 3I Atlas is artificial, it means we're being observed by intelligences capable of interstellar travel. It means we're not alone, and it means other civilizations have technologies that dwarf our own capabilities. That's simultaneously the most exciting and terrifying prospect in human history. But there's another fear that's perhaps more immediate. What if we're so committed to natural explanations that we miss obvious signs of artificial origin? The scientific community has been burned before by premature claims of alien visitation, and there's a natural tendency to err on the side of caution. But caution can become blindness if we're not careful. So where does this leave us? As 3I Atlas continues its journey through our solar system, we're witnessing real-time science at its most exciting. With fundamental questions about the nature of this object still hanging in the balance, the self-illumination mystery adds a completely new dimension to this story. Whether we're looking at exotic natural processes or something far more extraordinary, evidence of artificial technology, the next few months will be crucial for understanding what 3I Atlas really represents. October's close approach to Mars, the hidden perihelion passage, and December's Earth flyby will provide unprecedented opportunities to solve this cosmic puzzle. With each observation, we're getting closer to answering not just what 3I Atlas is, but what it means for our understanding of intelligence and technology in the universe. The universe is vast, full of mysteries, and 3I Atlas is proving that we're only beginning to understand what's possible out there. Whether it's a natural wonder displaying physics we've never seen before, or something far more profound, a visitor from another world, this object is reminding us that the cosmos still holds secrets that could change everything we think we know about our place in the galaxy. The fear isn't really about 3I Atlas itself. The fear is about what happens next. If this object is artificial, it won't be the last. And if we're being visited by intelligences capable of interstellar travel, then humanity is about to face questions we've never had to answer before. Are we ready for that conversation? Only time will tell. Craving the latest news about our galaxy and the universe? Subscribe now and stay ahead of the discoveries that could reshape our understanding of everything. Thanks for being with us. Leave a comment, like to show your support, and remember to hit that subscribe button for more exciting videos. See you next time.